In this video on waves, we're going to take a look at black body radiation. Let's go. The first part to be aware of is that all objects or bodies, no matter what temperature that they are, so look around you, choose an object, they will emit and also absorb infrared radiation. And if you had an infrared camera like this one, you would see exactly that. And you can see that we've got the warm areas a brighter colour and the darker areas are the cooler colour. In your exam, you're unlikely to have anything in colour, it will be in black and white. So that will be bright areas or white areas are hot and darker colours, so grey, black, will be cold. And the hotter the object is, the more energy it has, so therefore the more infrared radiation it radiates in a certain amount of time. Before I introduce the term black body, the first thing I need to say is there's no such thing in real life as an actual black body, but we can liken things to it. So what is it? A perfect black body is an object that absorbs all the radiation incident on it. This represents the black body, the black circle, and then we've got some arrows that represent the radiation that's on its way towards the black body. Because it absorbs all of the radiation, this radiation here, none of it then gets emitted or reflected. We can liken it to a warm day when we're wearing a black jumper. The radiation that comes in, the black body absorbs all of it, which is why we feel hot, compared to if we wore something white. So to emphasise, a black body does not reflect or transmit any of the incident radiation. But what do we mean by the word reflect? So we use the word reflect for, say, something like a mirror, when light comes in and bounces off from the surface. This does not happen in this case. And the black body does also not transmit any radiation. The term transmit can be likened to when light passes through a window. So when a wave can pass through or across a medium, so through the glass, for example, that's when we would use the word transmit, so pass through. And again, in a black body, nothing can pass through. And this is where people may get a bit confused, because a good absorber is also a good emitter. So a perfect black body is also the best possible emitter. But we've just said nothing can be transmitted or reflected. So what we mean is the light comes in, or the radiation comes in, it gets absorbed, but what comes out is different to what comes in. Let's take a look. So an emitter is a material that sends out energy. I've already mentioned that a black body doesn't actually exist in real life, and we do call it a theoretical object. However, stars, although they're not black, are considered to be like a black body, as they emit most wavelengths from the electromagnetic spectrum. A star, or like our sun, will emit a continuous range of electromagnetic radiation, which is at different energies. So if we have a look along the bottom here, we've got the wavelength. Going up, we have the intensity of radiation, so how much radiation there is. And we can see the peak wavelength just here is in the visible light region. And that's probably no surprise, because the bulk of our energy we can see in the form of light. However, when we go out, particularly in the summer, ultraviolet tans our skin. And the other side, all of this area, well, that's the warmth that we feel. Infrared is the posh name for heat energy. So there's a range of different energies that the sun gives us, or a range of energies that the sun emits.